Hi guys, so today we're going to look at is the modulus. You can see I've got a number line written down with a couple of values on it, so we'll just speak about the modulus. The modulus essentially is the distance from the origin to a particular point on a number line. So it's the distance, and we know that the distance can't be negative. You can't have a negative distance. So the distance from here to here is in fact 4. The distance from here to here is 3. And all the modulus does is it measures the distance. So, for example, if I draw another number line here and I'll just use the value of 4 and minus 4, then the distance from here to here is 4, and the distance from here to here is also 4. So, how do we write modulus? Well, in order to write the modulus, what we do is we basically use two straight lines like this. So, modulus of 4 would be equal to 4, because that's the distance from the origin, which is 0, to 4. The modulus of minus 4 is also equal to 4, again, because that is the distance from the origin to negative 4 here. This gives us an important property for the modulus, and we can say that if the modulus of x is equal to a, so where a is any number greater than 0, then x is equal to a, or x is equal to minus a. So let's have a quick look at an example on this in action. So suppose that we were asked to solve the equation x plus 3 all modularized is equal to 2. Well, that essentially means that we can say there's two solutions to this. We can say that x plus 3 is equal to 2, or what we have is x plus 3 is equal to minus 2. And we can just solve them as we normally would, and we get x is equal to minus 1 here, or x is equal to minus 5. So there's the two solutions. And if you put them back into the original equation, so if we put those numbers back in, so we've got x equals to minus 5, so minus 5 plus 3 is minus 2, and the modulus of minus 2 is 2, and here minus 1 plus 3 is 2, and the modulus of the 2 is 2, so that's why you can see that both of these actually work. Now the second modulus property we have to be aware of is that if we have the modulus of x is equal to the modulus of y, then x is equal to positive y, and x is also equal to negative y. So again, what I'll do is I'll go through this with an example. So we're going to solve. In this case, we're going to solve 2x minus 1 modularized is equal to, and it's x plus 2 modularized on the other side. So what we're saying is that we keep this one positive, so 2x minus 1 is equal to the positive right-hand side, x plus 2, or what we have is 2x minus 1 is equal to minus x plus 2. Just sticking a bracket there. So we'll solve the first one on the left-hand side, and we get x is equal to 3 as our first solution. Or if we solve this one, we get 2x minus 1 is equal to minus x minus 2. That means what we're going to get is 3x is equal to minus 1 on this side, and x is equal to minus a third. The third modulus property we've got to be aware of is that if we have the modulus and we square it, that's just equal to x squared, which of course makes perfect sense. It doesn't matter, because if it's negative squared, it's going to be a positive anyway. Okay, an example for this would be, so let's try m plus 1 all modularized is equal to the square root of m squared plus 5. So here, what we're going to do is we're going to square both sides. We just mainly to get rid of the root, to be honest. And we're going to get m plus 1 all squared is equal to m squared plus 5. Okay, get the bracket out. We get m squared plus 2m plus 1 is equal to m squared plus 5. Notice there's m squared on the left and the right hand side, so they're going to disappear, so that and that will go. And we are then left with 2m plus 1 is equal to 5, 2m is equal to 4, therefore m is equal to 2. So, there are three really important things that you need to know about modulus, or moduli, which is the plural. The first thing is that if we have this form here where we have a modulus is equal to just a number, essentially, then x is equal to a, or x is equal to the negative of a, all right? And very easy to solve. All we do, as you can see here, is we split it up into two. This one's equal to the positive, this one there is equal to the negative. The next one, if we have two moduli equal to each other, i.e. x, modulus of x equals modulus of y, then x is equal to the positive y, but x is also equal to the negative of that y. So again here, if we had a look here, 2x minus 1 is equal to the modulus of x plus 2. So positive is equal to positive. Solve. For the next one here, positive is equal to negative of this one here, and again solve. The last one we've got to do, or the last thing that we need to know about moduli, or how to use the modulus, is that if we square it, it just becomes the square. So here you can see this modulus here has been squared, so all we do is what we'd normally do, square it out, and then solve from there.